Okay, now let us start with the first example of washer. So now our focus will be on the washer method. So let's say we are dealing with this kind of question, the region bounded by the curve y equals to x squared plus 1 and line y equals to 3 minus x is revolved about the x-axis to generate a solid. Find your volume of solid. So now let us try to transfer the information to the whiteboard. So we have x squared plus 1, y equals to 3 minus x, okay, and it's revolved about the x-axis. So make sure you transfer the information correctly there. So the first step, always what we did in our previous example, which is we are going to apply what we call as sketching a graph path, which is here we are going to use the y-axis and x-axis. So this is our y and this is our x. For sure here we are going to have our origin there. So y equals to x squared plus 1 is basically a smile graph. Intercept at positive 1. So here let us try to draw a graph of it, which is we are supposed to get a smile graph. Intercept at 1. This is what we call as y equals to x squared plus 1. Okay, so let's use another pen for us to find the y equals to 3 minus x. I think red pen should be suitable here. So y equals to 3 minus x is basically referred to the straight line equation, which is we can write it as y equals to negative x plus 3, y equals to mx plus c. So then you can see that we are going to have the intersection at y, which is plus 3, and it will be y equals to negative x. So y equals to negative x is supposed to be something like this, and y negative 3. So you are going to put it, because this is 1, so 3 will be somewhere here. So let me try to draw a straight line. It's supposed to be a straight line. Intercept at 3 there, positive 3. So this is what we call as y equals to 3 minus x. So I think you can interpret where's the area of bounded region, which is, it will be somewhere here. Okay, so this is the value of your area. So now let us move on to the slicing part, which is we are going to rotate it about x-axis. So in order for us to determine the slicing, it will refer to the x-axis rotation. So we are going to rotate this one with respect to x. So here we can see that our equation should be, to find a volume, it should be from A to B for ax, because we are going to rotate it about x-axis. The same principle apply also for this method. Alright, so here let us try to deal with the slicing part. So since we try to rotate it about x-axis, so your slicing part should be perpendicular of it, which is it should be a vertical slice. So now let us try to slice it vertically. So you can slice it anywhere as long as it is within this within the shaded region. So let's say I try to slice it somewhere here. Okay, so basically we are going to see, or if we try to rotate it about x-axis, so you are going to have another object somewhere here for the slicing, which is it will create a big circle from the end of this part to end of this part, and we are going to also have another circle from the end of this part. So now let us try to extract the circles that we have. So we have a circle, a big circle, something like this. Okay, although it's something like ellipse, but you just pretend that you see a circle there. And you have a small circle on it. But both of it sharing the same center. You have the same center. So what we can see from the graph here, basically from here to here, you can see that this is our inner radius. Because I think I already showed you in the previous video that we are going to use inner and outer radius. And we are going to have our outer radius should be from here to here. This will be our big R. So from the formula, we can say that in order for us to find the volume, it will be an integrals from A to B. And the area here is given by the area of circles. So since we have two circles, we are going to minus both of it, which is the big circles minus with a small circle. So it's supposed to be a small one. With respect to x. Okay, since we have the common value of pi there, so I think it's better for us to put it outside, because our concern is on the part of the variable axis x, which is here will be a b r x squared minus with, so squared this should be somewhere here, minus with rx power dx. So now let us try to see what is the value of rx. But before that, I think it's better for us to put a limit there, a and b there. So we should know that when we deal with the with respect to x, because we deal with the with respect to x, the value of a and b here also must be something that related to x. So here is basically the value from, let me draw it again. So you have something like this. So the value of x would be, this is your value of a, and this is the value of your b. This is actually taken from this graph. So I try to put it again because I think the circles is interrupting our side. So the value of b is taken from here, but from our sketching, okay, we cannot see anything there. What is the value here? We cannot, but we know that the value must be in terms of negative, and the value is must be positive because at the middle here we get 0. So how about the value here? And how about the value here? So in order to that, if you try to examine this graph, we can see that the blue color intercept with the red color, which is the red color is given by y equals to 3 minus x, and the blue color is given by x squared plus 1. So let us try to equate them. So you are going to get here x squared plus with 1 is now equals to 3 minus x. So now our objective is to find the value of x so that we can find the value of our limit there. So we can bring all the value of your right hand side to the left hand side. So you are going to get, just combine it into the black color. So you are going to get here x squared plus 1 minus 3 plus with x equals to 0, which is we are going to bring all these things into this part. So x squared plus x 1 minus 3 will be minus 2 equals to 0. So try to factorize this part. So you are going to get two values there equals to 0. So if we try to do the factorization technique, so we are going to get the value of x is 1 and negative 2. So we can see that the value here is negative 1 and the value here should be, sorry, it's not 1, it's supposed to be negative 2 here, and this is supposed to be 1 there. So your equation now will be volume equals to pi integrate negative 2 up to positive 1. Okay, now it's time for us to find the value of r. So r is taken from here, big R is from the upper part towards this one. So you're going to see that if we try to calculate that, let's say this is our center. So center is somewhere here because you must have a equivalent distance from the upper part to the bottom one. So here a big R is, in order for us to calculate, it must be this part, up minus bottom, top minus bottom. So this one will be 0, y 0. This one will be y equals to 3 minus x. So it will be 3 minus x minus with 0. The upper point minus with the lower point. So you are going to get here, it will be 3 minus x to the power of 2. This is for the value of your big R. Minus with the small r. Small r here is given by this part. From here to here, small r. As you have the small one, blue color. So it's still 0 here at the bottom. And here the value will be lies on the blue color, which is, blue color here is taken from x squared plus 1. So you are going to get here x squared plus 1 to the power of 2 dx. Alright? Okay, you can try to pause the video and try to examine again how I get the 3 minus x squared minus with x squared plus 1 dx. And then you can solve for the equation. Okay, you can try to solve the equation. Okay, it's quite long because I ran out of time. I already write it for you. And try to verify my calculation later on. If I do mistake, please make sure you notify me so that I can make a correction. So I suppose the final answer is 1128 divided by 45 unit cube because we are calculating for the volume. Okay, you can try the question B there, but here please be careful because you need to know how to sketch the graph by your own. Okay, so I left this one as your own exercise. Is it possible? So if you have any question regarding this part, I want you to ask me by using a telegram or any means that you can reach me. So next, in the next topic, we are going to go for a cylindrical shell method, which is the last part of our chapter 3. Okay, so see you in the next video.